Okay, kind of a part two to my video I just did on complete the square. This is solve by completing the square. So let me do one or two examples on this. Yeah, maybe three. Some that start out a little simpler and some that get a little harder along the way. Words. All right. So let's see. Where's the one? Let's just start with the basics. X squared plus 6x equals -2. Now, there are various ways that these problems can start out. We could have x squared plus 6x plus 2 equals 0, but you got to remember from the last video and lesson, this is ax squared plus bx. When the problem asks you to solve by completing the square, this is not actually c. This is the thing we want to get rid of. In addition, this problem could also be represented by x squared equals -6x minus 2, and you have to recognize that you need to pull the b back over to this side. So let's get started. The method stays the same for complete the square. There is no GCF to pull out here besides 1, so we just proceed with our problem like normal. We need to find c. So x squared plus 6x plus whatever c is going to be equals -2. Now, instead of subtracting c on the same side, we're going to add it to the same side. Or the other side, excuse me. This is a property of equality. What we add to one side, we must also add to another. The reason we subtracted in the original one was because we're trying to make sure we're not adding too much to one side. So let's see here. B over 2 squared. That's 6 over 2 squared, which is 3 squared, which gets us 9, which means we're also adding 9 over here. Edgenuity seems to like to do a lot of steps in one, and that's fine, but please take this step by step. 9 equals 7. To convert to perfect square form, we need to copy the symbol of b and divide b by 2 and square. And here we go. Now, for the solving part. Complete the square has remained roughly the same, but if we are solving for x, we need to take the square root of both sides. This would create, for this one, x plus 3 equals plus or minus root 7. We can't take the root of 7, so we leave it as it is. Subtract 3 from both sides, and we have x equals -3 plus or minus root 7. That is x by itself. I don't know if Edgenuity is going to ask you to actually take the square root of 7, find the decimal, then both add or subtract it. Because remember, this means -3 plus root 7 and -3 minus root 7. Those are both of the answers. They may ask you to actually crunch those numbers, and that's fine. You usually don't need to, but they might. Let's move on to another example. And let's see, where was my second one? I want one with the GCF. Yeah, there we go, that'll do nicely. 2x squared equals 12x plus 54. My very first step for this one is not actually really setting anything up. It's just pulling things to the correct side of the equal sign. Ax squared and bx are on the same side. My first step will be pulling out the GCF of 2. Sometimes you might not think you have a GCF, but you always do. Even if it's just one, or even if it looks like you can't pull it out of both terms, you can. And I'll show you in the next example a little more difficult of a problem. So, b over 2 squared, -6 over 2 squared, that's -3 squared, so that is, another plus 9. Difference on this one being we're adding 2 times 9 to the other side because the GCF is 2 and then multiply by 9. On the previous problem, the GCF was just 1, which is why we didn't have it over here. Okay? One step at a time. 2x squared minus 6x plus 9 equals 54 plus 18, so 64, 72. I believe Edgenuity may have taught you to, instead of taking out the GCF, just divide the whole problem by 2. There's nothing wrong with that. It's just a slightly different method. And when you're solving it, you're going to divide by 2 anyways, which you'll see after I convert this to vertex form. So 2x minus 3 squared. Again, to convert to vertex form, copy the symbol from b and divide b by 2. Equals 72. Now comes the solving part. Don't take the square root until you've gotten the binomial by itself. Divide both sides, oopsies, by 2. X minus 3 squared equals 36. Ooh, that's good. That means this one will work out nice since you have a perfect square. Root of both sides. X minus 3 equals plus or minus 6. Add 3 to both sides. Now, in this case, we can actually solve for an answer, so we will. We're going to have 2 answers. 3 plus 6 and 3 minus 6. So 3 plus or minus 6. It's the same thing. 3 plus 6, our first answer is 9. 3 minus 6, our second answer is negative 3. Watch your negative signs on that. All right. Now, my very last example will be one that's actually from Edgenuity. One of my other classes, a student was a little bit ahead, and I helped him out with this problem. Fractions. Fractions are not as big a deal as some people make them out to be, and I'd like to show you why. 2x squared plus x minus 4 equals 0, solved by completing the square. Very first thing I'm going to do is kick that 4 over to the other side. Now, this is what I was mentioning in the previous problem of you may not think there is a GCF, but there is. Now, the way the way Edgenuity has you do it, they say, hey, divide the whole thing by 2 and make x squared plus 1/2 x equal to 2. You can do that. I prefer pulling the GCF out because if we were converting to vertex form, that's what we would do. I like keeping consistency. So pull the GCF out of these two. And like I said, it may not look like there's a GCF, but technically you can make 2 the GCF. Because if I distribute this 2 back in, you best bet this is what I get back. So anytime there's a number in front of x, you can make that the GCF. It's just that you divide the 1 in front of x by your GCF. For example, if this was 3x squared plus 4x, I could pull out the 3 and make this 4/3 x. Distribute back in, the 3's cancel out, and you're left with 4x. But let's continue with the problem. 4. When you're dividing a fraction by 2, all you are doing is doubling the denominator, because that is what it means to cut a fraction in half. 1/4 squared. When you're squaring a fraction, you're just squaring the top and the bottom, so it's not that bad. 1/16. So like if I asked you to square 2/9, guess what? That would be 4/81. Don't make too big a deal about it. I promise it's not. Fractions are just 2 numbers stacked on top of each other. Now, we're also adding 2 times 1/16, which means, yes, we're going to have to add fractions of unlike bases. That's all right. Take it step by step. 16 equals, now let's go over here. 2 times 1/16, that becomes 4 plus 2/16. I could convert these both to 16, but I think I'll shrink this 2/16 down to 1/8 first. Every whole number is a fraction over 1. So I need to multiply that 4/1 by 8. So multiply, we'll scoot this over a little bit. Plus 2/16. There we go. So multiply by 8. That gets us 32/8 plus 1/8. That gets us 33/8. Okay. All right. And that's, not exactly nice to look at. But That's okay. To perfect square form, the idea stays the same. X plus, divide this 1/2 by 2, that's 1/4 squared, equals 33 over 8. All right, now we're going to solve. Start by dividing by 2. Again, when you divide a fraction by 2, you just double the base, because that's the same as multiplying by 1/2. So 33 over 16. Take the root of both sides. I forgot to write my squared. Luckily, that base is a perfect square. That makes solving a little bit easier. We have the root of 33 over 4. Again, taking the square root of a fraction means you take the root of both the top and the bottom. We can't take the root of 33, so we just leave it as it is. And thankfully, with this problem, and don't forget the plus or minus, we cannot combine these, so our answer is -1/4 plus or minus root 33 over 4. So, fractions really are just one number stacked on top of another. When you square a fraction, you square both the numerator and denominator. When you take the square root, it's just taking the square root of both numbers. So my best advice for fractions is try not to overcomplicate them and try not to let them psych you out. And that's that.